Bismillahirrahmanirrahim. Now we are going to learn about large language model, which is commonly known as LLM. LLM stands for large language model, a type of artificial that understands and generates human-like language. So as the word language by itself is indicating in large language model that we want to use machine learning to generate human-like language or human-like text or human-like speech. And the word large means this model uses large set of data for the training. These models are trained on vast amounts of text like books, websites, articles, and use complex mathematical structures to learn patterns, grammar, facts, reasoning, and even some level of logic. So from here you can understand that to generate text, we don't just need to understand the language, the grammar, or vocabulary. Actually, we need to understand the facts, reasoning, and the pattern of writing a text as well. Some famous LLM models are GPT, most commonly today is GPT-4, Gemini used by Google, Claude, and Llama or LLAMA by Meta. LLMs are trained on billions or even trillions of words. First of all, to generate any text, a good vocabulary is required. So for that, we need billions or even trillions of words. They learn word associations, sentence structure, and contexts. As in previous lectures, I have explained you what is the importance of semantic. Here also, just knowing the meaning of the word is not important, but how it is used in the sentence is also important, and how the sentence is structured is also important. So the association of the words, the sentence of the structure, and context are also important to generate text. Training is done using machine learning, especially transformer architecture like GPT. How GPT works, I have lectures on that, how this generative pre-trained transformer works. If you want to get more into detail how GPT works, you can watch those videos. Text is broken down into tokens. First of all, the text is broken down into tokens. What text? The text which the user will input to give a command or instruction to generate the text. It is like a prompt that will be passed to the GPT model to generate the text. So the text is broken down into tokens, which are small units like words or parts of words. For example, playing might be split into play plus ing. Why? Because play is the actual word and ing is just its modified form. At the core, an LLM's job is to predict the next token, word or subword in a sequence. This is how LLM works. Actually, it works on the basis of prediction, and it has to predict the next token, which actually means that next word, what will be the next word after each word, according to the previous words or the words which the sentence has got so far. So for example, if you type the sun rises in, it will likely predict east. Now this word east is predicted on the basis of these words, that where it will learn that we are talking about sun, and what is happening with the sun, it is rising. So accordingly, then this predicted word will be east. So as you can see that not only we have to understand the words in the sentence, the prompt which we are providing, but also their sequence of the words is also important, and whether it is an action or it is just a description, what kind of word that we are using in the sentence. So here The sun rises in the east. Rising is a verb. So sun rises from the facts, as I explained you, that it requires to know the facts as well, and the fact is that the sun rises in the east. So here, from that fact, it predicted that the most likely the next word will be east. But for that prediction, first we need to train the model. After initial training, the model can be fine-tuned for specific tasks like medical advice, coding help, etc. So once you have trained a model, which is a general model, can predict any kind, can generate any kind of text, and then you can fine-tune it, and we will see in future that how these fine-tuning works with the existing model, how we can make the existing model a fine-tuned model. We can modify a model for a specific purpose like medical advice, education advice, law advice, things like that. So for example, ChatGPT was fine-tuned to have safe, helpful and polite conversations. Of course, ChatGPT covers a wide range of topics. As you know, if anybody who has used ChatGPT knows that it will answer you almost all kind of questions. So it means that we have trained ChatGPT for different kind of information. If that information is not available, that fact is not available with ChatGPT, then it is not trained to use that information, then it cannot really generate that text. Once trained, the model can be used to generate responses to input text. So first, as we know that in all kind of machine learning methods, we must first train the model, and that training is the most essential part, how refined your data is and how large that data is and how properly it is labeled if it is a labeled data. It doesn't think but uses learned patterns to produce likely and coherent outputs. As I told you that it works on the basis of probability. Prediction works on the basis of probability. So what it uses the learned patterns to produce likely, means most probable, and coherent outputs. So what can LLMs do? What kind of tasks they can perform? Text generation. They can generate text. They can do the translation from English to Urdu or Urdu to English. Summarization, summarize long documents. Question answering, provide factual or context based answers. This question answering is very important because here we have to keep the track of the previous questions and their answers, and the next answer will be based on the previous conversation. Similarly, code generation. LLMs can generate codes. They are used for chatbots, power customer service or assistant bots. Reasoning and logic, like solving puzzles, simple math or logical tasks. Now, there is a general misconception that LLMs are intelligent, or even machine learning is intelligent, or AI is intelligent. So there is no such thing as intelligence in computer. So no, not in human sense. LLMs are not intelligent like human beings. LLMs don't understand meaning like humans do. As I told you that we have to, when the text is to be generated, then the meaning of that text, the semantic meaning of that word is to be understood. But it cannot understand the semantic meaning of the word as we humans do. So actually it works on the basis of statistics and probability. Don't have beliefs or consciousness. Work by statistical pattern matching, not real comprehension. As I just told you that it works on statistical pattern. It cannot really comprehend or understand what really that word means or that sentence means. But they can mimic intelligence very well, enough to pass exams or even fool people into thinking they are human in some contexts. So if you have done a long chat with ChatGPT, have done some kind of argument with ChatGPT, then you will feel that it is going to argue with you just like a human being. You will not feel that it is done by a computer. Now, to generate these text, a method is used called auto-regressive decoding. So what is auto-regressive decoding? Auto-regressive decoding is a method used in natural language processing (NLP) and generative models like GPT and T5 to generate sequences like text one token at a time, where each new token is generated based on previously generated tokens. As I told you that each new word, here by token we means word, each new word, or whether we call it word or token, each new word or token is generated based on the previous words or previous tokens. So start with the prompt input. For example, you have given the prompt, the weather today is, that's it, the weather today is. Now the LLM has to predict the next word. So suppose it, now first of all it will understand that it has to make the prediction related to what? Weather. So it has got to understand this word. In the understanding, by understanding I mean that it should know from training that what weather refers to. So from training, for example, it knows that a weather can be rainy, snowy, sunny, hot, cold, and things like that. So from that training it will predict that for example the weather is sunny. It could have predicted weather is rainy, it could have predicted weather is hot, weather is cold, and anything like that. Then it appends this token to the input and uses the new sequence, the weather today is sunny. Now if it has to make another prediction, then it will use all these words, the weather today is and sunny. So for example, to generate the next token and, because it say sunny and something like that, hot or something like that, humid. This process repeats until a stopping condition is met. So this process of prediction of words for a sentence keeps going on until the stopping condition is met, which may be maximum length. For example, you have provided what the maximum length of a word sentence should be or can be, or special end of sequence token. So this process is shown mathematically over here. For example, the first word is predicted py1, then this py2 is conditional probability of y2 given y1. So whatever is the probability of y1, the probability of y2 will be based on this probability of y1. Then probability of y3 will be based on y1 and y2, and so on. Now what is the key characteristic of LLM? Must wait for the previous token to be generated before the next. As I told you that if the input was, prompt was the weather today, the weather is, and the next generated token is sunny, then it has to take into account all these previous words. So it cannot generate the word next to sunny before it generates sunny. After that it will again take all the sentence, and then again it will generate the new word, and then again it will take that whole sentence into consideration and then generate the next word. So this is sequential process used in models like GPT, T5 and BART. All these text generation models use this method of LLM, and decoding strategies are greedy decoding, beam search, and sampling. We will shortly see an example of Python code where we will use either greedy decoding or sampling. For example, the input is once upon a time. Auto-regressive decoding may generate there was a dragon. Now first how this will happen? First of all, once upon a time, first it will generate there. then it will take into consideration once upon a time there, then since once upon it is talking about past, so most likely the next word should be past tense, so it is was, and because it is singular, so the next word is was, then a, and then dragon. It could have been something other than once upon a time there was a dragon, once upon a time there was a king, something like that. So each token depends on everything generated so far. Non-autoregressive models generate multiple tokens in parallel, not one by one. But there is another method where you can generate multiple tokens in parallel, but it is not very efficient. These are faster but often less fluent or coherent. Now we see a simple example of text generation using GPT-2. Why we have used GPT-2 over here? Because GPT-2 is open source. To use GPT-3 or GPT-4, we need to use API. So we will have another lecture on how to use GPT-3 or other APIs of LLM to use. But at this moment we are using the open source model, how to use an open source model like GPT. So now first of all we import two modules, GPT-2 LM head model and GPT-2 tokenizer from transformers library. As you can see that this GPT-2 is the model and this GPT-2 is the tokenizer, which will tokenize the input. Next we have imported another library, Torch. What is Torch? Torch is the core library of PyTorch, an open source deep learning framework developed by Facebook Meta. It provides a powerful and flexible platform for building and training machine learning and deep learning models in Python. So in this simple example we will need two libraries, transformers and Torch. Now we load pre-trained GPT model and tokenizer. Here model name is GPT-2. We can also try GPT-2 medium and GPT-2 large. And if you want to generate more complex sentences or text, then you can use GPT-2 medium, and even if you want to use more complex sentences, then you can use GPT-2 large. But of course there is a cost for each one, that it's going to take more time and more space than GPT-2. So now first we create instance tokenizer using GPT-2 tokenizer class and method from pre-trained model name. So here we are using this GPT-2 model, pre-trained model for the tokenization, and for that we have used from pre-trained method of GPT-2 tokenizer class. We use GPT-2 LM head model class, and again it has also got a method from pre-trained, and we pass this model name to it, so it will create a model for us. Next we set the model to evaluation mode, because here we are using the model to generate the text. If we had to train the model as well, then we would have used training mode, but here we are using evaluation mode because the model is already trained, GPT-2, and we have to use that model to generate the text. So we have set it model.eval. Now this is the prompt, the future of artificial intelligence. Based on this prompt it will generate the text for us. So this is a prompt, input prompt. Input IDs is equal to tokenizer.encode prompt and return tensor is equal to pt. So as you can see that after creating the instance or object of tokenizer over here, we are using .encode method, and we have passed prompt as its argument, and return tensor is equal to pt. So we have told that this encode will return the tokens in tensor form. So the tokens will not be in the regular Python list form, but they will be in PyTorch tensor form. Next we use with torch.noGrad. This line is a typical PyTorch context manager used to gradient calculation. It saves memory and speeds up computation. It tells PyTorch we are just using the model to predict, not training it. So no grad means that gradient calculation should not be performed, because here we are using it for evaluation or for the prediction or to generate the text rather than training it. So torch.noGrad means that we are not going to compute the gradient descent. With keyword is used to wrap the execution of this block of code within this context manager, that is torch.noGrad. Next, output is equal to model.generate. So what is model.generate? Model.generate is a convenience method provided by Hugging Face for generating text from a prompt using auto-regressive decoding. I have already explained you what is auto-regressive decoding, that is word by word generation, but this method is provided by Hugging Face. Model.generate is provided by Hugging Face transformers library, not directly by GPT2 LMH head model, but it works through it. So now what are the parameters of model.generate? First of all, input IDs, that is we already have computed here. This is tokenized values of the input of the future of artificial intelligences. It will be tokenized and that is stored in input IDs in PyTorch tensor form. So it will be passed to here, this model.generate. That is why we converted this into tensor PT form. Why? Because this model.generate expect this input to be in this PyTorch tensor form. If we will not convert it into PyTorch tensor form, it will be in list form or dictionary form or any other form, then it may generate error. Now maximum length is equal to 100, maximum number of tokens to generate this, and number return sequences, number of sequences to return. Temperature is equal to 0.7. This controls the randomness of predictions. Lower value means more conservative, focused, for example 0.5. Higher value means more creative, random, like 1.2. So if you have set it more higher side, then it will have more randomness, but be careful, because having too much randomness may generate meaningless sentences. So we want the text to be creative, but we don't want it to be meaningless. So going on too much higher side randomness, it will generate senseless sentences. Top P is equal to 0.9. This is nucleus sampling. Consider the top tokens whose combined probability is greater than 90%. Filters out low probability unlikely tokens, makes output more natural and diverse than greedy decoding. So as I told you before when I was showing you the slides, that we use either sampling or greedy. In this case here we have used top P. There is a little small comparison of top P versus top K. Top K chooses from top K tokens, fixed size, and top P chooses from top P percentage cumulative probability tokens. Means that in top K we just tell that you have to take top 5 tokens, for example, without considering any probability or anything like that. But here we are not choosing the fixed number of tokens, but we are saying that whatever the cumulative probability is, for example we have said 90%, so it may have 3 tokens, or it may have 4 tokens or 5 tokens, whatever the threshold we have defined for top probability. Whenever that condition is met, so the tokens will be picked according to that value of probability. And then do sample is equal to true. It means if the false model uses greedy decoding, and if it is true, it means the model randomly samples from possible next tokens. better for creative tasks like storytelling. Here now we have to generate the text, and we use tokenizer.tcode. So this output will be passed to this one. It will take these tokens into as an input, and it will convert them into words. So as you can see from this example, that actually it is all just mathematics. It is in the background, it is just working on the numbers. So this will actually generate the tokens, not the words. This output here, it will be in form of numbers, not in form of words, and then it will be passed to this tokenizer.decode, which will convert it to the words and skip special tokens like added ones or comma, full stop, and things like that. And the text is generated, then generated text is displayed and it is printed. I just run the example. So first of all, you can see that it has generated a warning. I will explain you what that warning does mean and how we can overcome this warning. First we focus on the generated text. So from the prompt that the future of the artificial intelligence is, then it generated in the hands of people with a very different understanding of the world. We have the tools to solve problems, and solve problems on much larger scale than we have now. We have the tools to create new kinds of problems and problems that we think are really, and things like that. As you can see that this is not really very creative writing. Why is it so? Because we have used small GPT-2. If we use GPT-2 medium or large, then we can improve this one. Now, will it generate the same text every time? No. For example, if I run it again, now the text is different. The future of artificial intelligence is unknown. What is certain is that the development of artificial intelligence will continue unabated, and that's where we are headed. It is no secret that AI has been around for a while and things like this. So you can see that here, every time I run the program, I run this code, it is generating a different text. Now we come to this point, what that this warning is saying. The attention mask and the pet token ID were not set. As a consequence, you may observe unexpected behavior. Please pass your inputs attention mask to obtain reliable results. Setting pet token to EOS token ID 50256 for open end generation. Now, as we are using GPT-2, by default GPT-2 does not use attention mask and this padded tokens. So we need to add them. To add them, what we can do is that I simply, first of all, I add it into input IDs. Here you can see that I have added padding is equal to true. What is padding? Padding is very simple concept. As we have set a exact length of a sentence. For example, we say sentence is for 100 words, but suppose the input we have provided is say only 10 words, or prompt is about 20 words. So the rest of the words will be padded, means they will be assigned a dummy token ID, although that dummy token ID will not be considered until they are replaced by proper words. So how do we make sure, or how do we tell the model that from where these dummy IDs are starting? For that we use attention mask. So what it will happen, for example, if I have got, suppose here the words are the future of artificial intelligence 1 2 3 4 5 6, and suppose we have got maximum length of the sentence is 10 words. So what will happen is that it will assign an ID to the future of artificial intelligence is, and then for the rest of the 4 words it will generate a dummy token ID. But that now we have to tell the generator that there are dummy IDs after is. So what will happen is that this attention mask will assign, so for example, 1 to this one, first one, second one, third one, fourth, fifth, and sixth. After 6, it will assign 0 to rest of these token IDs. So from that it will know that after is, although token IDs are there, but they are just paddings, they are not real words, and it will ignore them when considering to generate the next token. How do we do that? For that we use attention mask. Attention mask is equal to torch dot ones like input IDs. So what it will do, that it will assign 1 to all these input IDs and rest will be assigned zeros. Means the padded ones will be assigned zeros. Now instead of this one, we use another modified torch dot no grade. I have block commented this one and I uncomment this one. So now here you can see in this one there are two more arguments. Attention mask is equal to attention mask, and this pad token ID is equal to tokenizer dot pad token ID. And where I have this one, yes, the pad token ID is the ID assigned to a special padding token used equalize sequence lengths in a batch. If your input is shorter than maximum length of the sentence, then the add padded tokens at the end of each to match the length. So this will be added, and then using this attention mask, only these words over here or tokens of these words will be assigned 1, and the zeros will be assigned to the padded tokens. So now if we will generate the text again, we will not get this warning anymore. Now the generated text is the future of artificial intelligence also on the horizon. In the next few years, researchers from the University of California, Berkeley, and the University of Illinois at Chicago will start to use computers to build artificial intelligence systems that can learn from and improve on humans and things like that. Now you can see that the quality of the text generated by the same code has improved because of these two important things, padded token and attention mask. So you can understand the importance of these two things, padded tokens and attention mask, because every time the size of the maximum length of the text sentence must be fixed. That's it. I hope you have understood all these, how to write a code, simple code for LLM. And you can also understand from this example that you don't need to go for GPT-3 or GPT-4 every time. If you have to generate simple text, you can use LLM, this GPT-2, using GPT-2 medium and GPT-2 large. Of course, the output of GPT-2 medium will be better than this GPT-2, and this GPT-2 large will be better than GPT-2 medium. That's all for now. In next examples, we will see other examples of LLM.